So with that, I will go ahead and turn it over to Dr. Jeff Dukes, who is going to give us some myth busters and help us really understand some of these facts about climate change.
Great. Thanks, Melissa. And welcome, everybody. It's great to have you back for another in this series of talking confidently about climate change in Indiana and beyond. As Melissa said, we're going to go over myths today. This is Climate Change Mythbusters. And I want to start out by just sort of maybe asking the question of why are we here? Why do we need to talk about myths? Why are there so many climate change myths that we seem to need to deal with? After all, we've known about climate change and talked about it for a really long time. So the first science that really discovered the principles of greenhouse gases and suggested that maybe the planet would warm if we increased the concentrations of greenhouse gases in the atmosphere, that happened more than 150 years ago. It's older than the institution of Purdue University. And you can look into newspaper reports from 1912, in this case, that I'm showing you, and see that there was speculation back then that burning coal would raise the temperature of the planet by making the air a more effective blanket around the Earth and cause warming. So we've known about this for a long time. If you go back to 1965, 55 years ago, President Johnson got a report on restoring the quality of our environment. And that report talked about climate change caused by increases in carbon dioxide concentrations in the atmosphere from the burning of fossil fuels, and talked about many different negative implications of climate change. So if this has been a scientifically understood issue for so long, why is there so much misinformation floating around about it? Why are there so many questions? Why are people, coming up all the time with sort of strange theories about what's going on that differ from our actual scientific understanding of this? And why is it so controversial? Well, there are a couple reasons for that. And basically, it comes down to the solutions that people expect we would need to solve climate change. So some industries are threatened by some solutions to climate change. If you're making your money burning fossil fuels and creating carbon dioxide that goes into the atmosphere, then any regulation that would limit your ability to burn that fossil fuel, that is a threat to your industry, to the value of your company, potentially. And for some people, if they have a worldview that prefers limited government, extremely limited government, they might be concerned that to solve a global problem like this, you would need some large-scale governmental regulation. And if they don't want government regulation, then the solutions that they might foresee coming into play could be disturbing. And so they might be less inclined to want to go along with the science that is presented to them and try to find some alternative science that might alternatively explain what's going on and mean that we don't need to deal with the solutions that they're concerned about. So that can lead to myths. So if you look back at the history of our understanding about climate change, one industry that's known very well about climate change and the implications of climate change is the oil industry. So Shell Oil has internal documents that go back to the early 80s suggesting that models of climate change predict increasing CO2, increasing temperatures. And if you look at the bottom of this quote here from this news article, or from this Shell document really that's highlighted, it says, such relatively fast and dramatic changes would impact on the human environment, future living standards and food supplies, and could have major social, economic, and political consequences. So Shell knew about this, but nonetheless, they helped contribute to some of the confusion around climate change. Another company that contributed to this confusion was Exxon. They've put a lot of money into basically confusing the public on climate change, into organizations that will that will perpetuate some of these myths. But back in 1981, they had internal communications that were discussing the challenges of climate change, the problems associated with climate change. Their scientists understood it perfectly well, and yet they felt seemingly it was in their interest to perpetuate some of these myths. So that's, this interest of industries and people is how we got where we got. And it's the case too with organizations that have a worldview that they're pushing. So in this case, what I'm showing you on the left is a government report that came out in 2009 on what the implications of climate change are for the United States. This is the product of hundreds of scientists and many government agencies working together. This is peer-reviewed research. That means that not only did hundreds of scientists write it, but hundreds of other scientists took a look at it to make sure that it was accurate, that it was up to the standards of science, that it reflected the best knowledge of science. And then this, after much, much process, this was issued as a government report on the state of the science. Then 3 years later, the Cato Institute, a think tank pushing a libertarian agenda, had a few people who work there basically put together a report that then was trying to cast doubt on this, on the conclusions in the original report. And you can see the cover that they used. They tried to make it look exactly like the government report, except an addendum to it. They tried to make it look very official. And you can notice if you look closely on the front, whereas the US government report has annual temperatures, or really annual temperature anomalies, like the difference in temperature from an average over the whole historical thermometer record of climate. The global temperatures in the report on the right have just cherry-picked the most recent years where the trend was less apparent. And of course, if you put in more recent years than that, you'd see a string of record high temperatures, so that curve would be going up sharply again. So there's a lot of information on the disinformation campaigns that have been run, the myths that they've spread. There's a book by Naomi Oreskes and Eric Conway that goes through these. I recommend it. It's a little bit old now, but I recommend it for people who are interested in this. You can also see that some of the same people have been involved in casting doubt on climate change that were involved in casting doubt on the health consequences of tobacco smoke. So there's a sort of a cottage industry of disputing this science for maybe not very well-intentioned purposes. In any case, I recommend taking a look at this book, and you'll understand better the history of where these myths are coming from. These tactics, this misinformation that's been spread through a variety of organizations rather, and has managed to leak out through the media over the years, have really worked in confusing the American public about the state of understanding of climate science. So you can see here the results from a poll that looked at what Americans thought the scientific understanding was about human-caused global warming. So a third of the people polled didn't know that how many or what percent of climate scientists think that human-caused global warming is happening. There were some people thought it was a pretty high agreement among scientists that human-caused global warming is happening, but a pretty substantial number put that number as being lower, thought that there was some disagreement among the scientific community. The real answer is more than 90% of scientists understand that the planet is warming, and that warming has an anthropogenic or human-caused background. So this tactic has been working. These climate myths have been effective. So today we're going to try to go through some of them and debunk them. So there are hundreds of different myths that have been spouted over the years. And there is one site that does a really good job of sort of tracking down the different myths that have been suggested and debunking them one at a time. And they do it in a sort of in a basic way if you just want the basic information, or for many of them you can click on like an intermediate or an advanced explanation. I highly recommend this site if you want to check out some myths that you haven't heard today at the end of my talk. Again, there are about 200 of them listed at this site, and it is skepticalscience.com. So you see the link here. The origin of these myths, again, is that there is a fear of the climate change solutions. The origin of these myths is not scientific. So I'm going to go through some myths now for the rest of this time, and hopefully these are some of the ones that you're most interested in. The one that I think I hear most often is that it's just natural cycles. Well, sure, it's getting warmer now, but it's gotten warmer and warmer, cooler, and over the years, and right now it's got to just be natural processes. And now you've already heard from Dr. Hall a bit about the effects of these very slow changes in orbital cycles on the climate. And you've heard in our Basics of Climate Change lecture about the different factors that are controlling the climate, and certainly natural factors are involved. But the evidence does not suggest that those factors are the most important ones in the warming that we're seeing now. So it was several decades ago now that our climate started getting warmer than you would expect from all of the natural factors. And those natural factors are changes in our orbit, those very slow changes in our orbit, changes in the solar output over time, the strength of the sun, and changes in the amount of sulfate aerosols in our atmosphere that have been injected there by volcanoes. And you saw previously already some of the cooling spikes that happen when you get big volcanic eruptions like the one from Mount Pinatubo in 1991. Those changes, those variations from year to year cannot explain the warming that's happened. What can explain the warming is human-caused emissions. Now, there are human-caused emissions of aerosols that actually act to cool the planet, but at the same time, we're releasing a lot of greenhouse gases. And those greenhouse gases have a much stronger effect and act to warm the planet. Now, I will say that I'll bring in another myth real briefly here. Some people will say, oh, the scientists back in 1970 said there was global cooling, and now they say there's global warming, and they have no idea what they're talking about. Well, we've learned a lot since the early 70s. And at that time, there's still uncertainty about exactly how strong the cooling from the aerosols is. But back in the 70s, there was much more uncertainty in some scientific circles about the relative strength of the cooling from the aerosols and the warming from the greenhouse gases. And that got straightened out pretty quickly. It's very clear now that the warming from the greenhouse gases is stronger. But science advances over time, and you get better and better explanations of these things as you go. So the combination of human-caused emissions and the natural forces actually explain our current climate very well. And you can see that in this graph right here, where the observations of global average temperature are shown in black. The natural factors alone would lead to some sort of temperature trajectory in the green shaded area here. And when you put into the models natural and human factors together, then what you get is the blue shaded area, which closely matches the actual temperatures that we've seen over time. If you want to explore this in greater detail, these data come from a NASA analysis, but there's a really nice animation that breaks it down factor by factor at the website that's listed at the bottom of this slide. Okay, one other component of this, it's sort of a special part of myth number one, is that it's the sun, which of course is a natural factor, but I hear it all the time, and so I want to take a little bit more time to unpack it. So this is myth 1A. Now, basically, it's not the sun, just in brief. So if we look at the overall effect of the human-caused factors and compare that to changes in solar factors or changes in volcanic factors over time, we know that the human-caused factors are much stronger over the period, say, 1750 to 2011, shown here, or pick your other period. But certainly there's more uncertainty in the human-caused factors, mostly caused by the uncertainty about those cooling forces. but there's no doubt that those factors are much, much stronger in influencing our climate than the sun. And in fact, in recent years, that previous graph showed all the way back since 1750. In more recent years, if we look at the trajectory of energy from the sun here in the yellow and temperature in the red, we see that actually the sun is getting weaker in recent years as our temperature is going up. So temperature does not explain well, the sun does not explain well what's going on with our temperature. So not only has the sun been getting weaker, but there's another important thing that explains that it cannot be the sun, and that is that the stratosphere has actually been getting cooler. So the stratosphere is up above the troposphere where we live. It's a higher portion of the atmosphere, just above where jets fly. And if the sun had been getting stronger over time, we'd expect the stratosphere to be warming and the troposphere to be warming. But in fact, it's just warming down below here and cooling up above. And that suggests that what's really happening is we're getting a thickening of that blanket of greenhouse gases that covers the Earth, and that is trapping heat down below the stratosphere and warming up down where we are, or closer to where we are, and preventing that heat from going up and warming up the stratosphere. Another myth is that, it couldn't possibly be CO2 that's causing this warming because, and then you can fill in the blank, but it often might be something like, CO2 is just a fraction of a percent of the atmosphere. How could a tiny change in this fraction of a percent of the atmosphere actually lead to the warming that we're seeing? It turns out it's a big lever on climate, in part because it's so good at absorbing infrared radiation, and in part because it's a long-lived gas that stays in the atmosphere on the order of hundreds of years, as opposed to other things like water vapor that can come back and forth really quickly. The CO2 emissions, there's a lot more CO2 emissions from natural sources like soils, the microbes in soils that are respiring, and our plants that are respiring. There's a lot more CO2 emissions from all that than there is on any given day from fossil fuel burning. But the thing is, those natural emissions are balanced by photosynthesis, taking that carbon back up out of the atmosphere. And on the whole, it's a nice balance, as you saw in our Climate Change Basics seminar earlier. The fossil fuel emissions are not balanced by anything, and so they are contributing to this rapid increase in carbon dioxide concentrations in the atmosphere that are now 45% plus greater than they used to be before the Industrial Revolution. There are many different lines of evidence that show that it's the fossil fuel contributions that are leading to that increase, and that CO2 is a heat-trapping gas, as we've known for more than 150 years. So it is clearly the CO2 that is causing this effect, is the major driver. And some people might say, but there are benefits to CO2. CO2 is plant food. It's good for the earth or whatever. Well, it can boost plant growth in some situations where plants have enough nutrients, enough water. It certainly can boost the plant growth for some period of time. But if you look overall at the cumulative effects of CO2, there are implications for climate and the implications of climate change for humanity and for other species, then it's rapidly clear that CO2 is a negative overall. The third myth, lots of scientists disagree with each other. There's no consensus on this. The consensus is fake or something like this. Okay, well, that is, again, another myth. It's just not true. There are a handful of scientists who seem to, at least the vast majority of them, have some agenda, ideological, that get called upon again and again to try to dispute one aspect or another of climate change, and they tie themselves into knots repeatedly, trying to essentially bring up straw man arguments that something about climate change science is not quite right. The reality is there's a mountain of evidence, thousands and thousands of studies that back up the basic narrative about how greenhouse gas emissions are changing the climate, and that is having implications for the planet. And none of these handful of scientists have come up with anything that undoes that mountain of evidence. And furthermore, if you did, if you came up with something that was scientifically rigorous, that truly disputed the basics of climate change science, you would rapidly be the most famous and celebrated scientist on the planet, I have to say. But there have been many different polls that have looked at what scientists actually think on this issue. And depending on the poll and how you ask the question and who exactly you ask, the polls all range in the 90 percentages or up to 100% of climate scientists that agree that the climate is changing and humans are responsible. So here you see the results from a variety of different studies. But basically, it is the vast majority of scientists that understand and that this is going on. Here's a great one. Well, this is a cold winter. It's so cold this winter. What happened to global warming? There can't possibly be global warming. It's way too cold, right? Yeah, I don't always know what to do with this one, really. Like, that's not a real argument, right? Do you know how winter works is sort of my initial starting place with that. You can't possibly be serious. So there is year-to-year variability in temperatures, as we've seen, as we saw in Dr. Hall's wonderful presentation on Tuesday, right? From year to year, it gets warmer. You might have a warm year, you might have a cold year. You always get winter just because of the tilt of the Earth and the fact that it's orbiting around the sun. What do you even do when you get that argument, or somebody throws a snowball at you and tells you that climate change is a hoax? I mean, it's a little bit tough to deal with and tough to know whether you should take it seriously. But the bottom line is climate change is happening on top of all these other seasons. It's boosting the temperatures around the planet, around the year, but that doesn't mean it's making seasons go away. It is possible when you talk about like the polar vortexes that we've had in some of the recent years here, where we've had some really cold temperatures in the winter as cold air moved down from the Arctic and sat on top of us for a while. It is possible that that phenomenon is happening more often now because of climate change. There's some work that suggests the jet stream is getting wavier as climate change is progressing. And these waves in the jet stream, instead of sort of tying all of the cold air up in the Arctic in a little confined circular area, are letting that cold air escape in blobs down over the continents farther. That's possible. That is still a really active area of research, and we don't have a full understanding of whether climate change is tied to that yet. There's some indication it might be, but it's not certain. But the whole winter thing, I mean, come on, give me a break. Okay, the next myth. This is a pervasive one. It's that temperature records are wrong, and you're seeing that these surface temperature observations from weather stations, they say they're going up, but what's really happening is you're getting these urban heat islands, which means just that around, maybe you had a weather station in a rural area at one point, but now the cities are building up around them, and the cities have fewer plants, and the plants act to cool the surface, but as you get more roads and more buildings, you get more warming. And so over a long temperature record, you have to worry about the weather station recording warmer and warmer temperatures because you have more of these buildings and roads around them. Or more of another line of thinking on this is, more of the weather stations are in cities, and so you're seeing the warming in the cities as the cities build up, but that's just because of the cities, and it's not actual temperature records, or not actual temperature change, rather. Well, the real story is that that temperatures are going up in cities, and they're going up in rural areas, and scientists who are looking at this take into account when rural areas become more urban, they try to understand what the trends are around the different weather stations and take all of this into account. So it's not some brilliant insight that climate scientists who work on this for a living have overlooked. They work hard on that. I mean, I have here, do you really think that people whose career is based on understanding long-term temperature trends wouldn't take these things into account? Do you really think that you've had this brilliant insight that nobody else had? It's anyway. There was a prominent physicist at UC Berkeley who basically thought along these lines and said, oh, well, I'm sure that they're doing a horrible job of calculating global mean temperatures. I could do it better because I'm a brilliant physicist. And so he put together a team, and he got funding from the Koch brothers, who earn a lot of their money from fossil fuel, and from many other organizations, to put together a team that would basically, quote unquote, debunk these climate trends that we've seen. Well, what happened? Well, in the end, his team came up with numbers that were almost identical to all of the temperature records that the scientific organizations in countries around the world had come up with. And to his credit, he changed his mind. And he said, well, okay, I guess it's real. I guess it's really happening. And that, that group that he formed is actually continuing to this day. They're called the Berkeley Earth Surface Temperature Group, or the BEST group. And they actually do some great work. But we get this again and again. And I'm going to show you now the global temperature anomaly estimates from 5 different groups, including Berkeley Earth, as they're called here. And you can see how closely they align since essentially the beginning of temperature records on the surface of the planet. These different organizations, using different techniques to interpolate temperatures among the different weather stations that are available, weather station data sets that are available on the planet, and using different techniques to screen out which are high quality and low quality records and during which times, they nonetheless come up with remarkably close estimates to one another of what the temperature trends have been over time. And again, this is showing here as just an anomaly. It just says, what is the difference from an average temperature, in this case, an average temperature that was taken by averaging the overall global temperatures from 1951 to 1980 and saying, well, was a given year warmer or colder than that average over time. Another argument that's common with people who maybe know a little bit more about what's going on, and especially with people who read mainly some of the discussions going on in the skeptics sort of culture, is that the satellites say it hasn't warmed, or the satellites say it hasn't warmed much. So really climate change can't be a thing. You know, despite the warming surface temperatures that we see, the satellite record is maybe more comprehensive, and it's not showing as much warming. So to look at that, we've got to understand what the different temperature records are, how they come about, and what some of the issues with satellites are. So let's see if I can advance. Here we go. So a lot of text here, but basically we can look at atmospheric temperatures in a couple ways. If we want to look at them close to the ground, we can use the temperature gauges, the thermometers that we have a network of all over the surface of the planet at this point, and we get a lot of data. If we want to look at temperatures throughout the atmosphere, we have to use satellites, or at least one of the good ways to do it is to use satellites. They estimate temperatures through different slices of the atmosphere by essentially looking at particular wavelengths of light in the atmosphere and trying to understand from the essentially microwave reflections from those or emissions from the molecules in the atmosphere, the oxygen molecules in the atmosphere. They try to understand what the vibrations are in those molecules and infer temperature. And they try to infer temperature sort of throughout this column of air that they're looking at from way up above. And those records show less warming over time. They're fairly recent. They started in 1979 or so. They show less warming than the temperatures that are taken right down near the surface of the planet here with your typical weather station. And we don't fully understand why, well, they're different measurements, but we don't fully understand why the satellites are showing less warming than we might expect, and less warming than we see down on the ground. Part of it is that they're measuring different places, but also we would expect more warming than we've seen from the satellites. Now the thing is that thermometer measurements on the ground are pretty pretty straightforward, right? I mean, this is a technology we've had for, well, since the 1800s. And we can use a variety of things to measure temperatures on the ground, but we understand that. With the satellites, the measurements are challenging because, well, the sensors degrade over time, the orbits of the satellites degrade over time and change, and there are just a variety of factors that actually influence what those satellites are measuring, and it's difficult to correct for them all. And so you've seen time after time, these data sets of satellite temperatures have needed to be corrected in many ways. The people who are skeptical about climate change will often bring up one data set in particular, and I think they do that because it is generated by a couple of the scientists who are themselves climate skeptics. It's the University of Alabama at Huntsville's data set, because it's a couple scientists there who really do the processing on that. That data set has always been the lowest in terms of the amount of warming it's shown, and it's been particularly problematic in that people have spotted a lot of errors in the processing of that data set that have always seemed to bias the numbers even lower. And nonetheless, the warming that's seen in the satellite data sets is not inconsistent with what models expect. It is on the low side, but it's not inconsistent with that. So I guess the bottom line here is that I would say satellite measurements there is some work still to be done to understand the science of this, but they're a much poorer metric for what's actually happening in terms of warming than surface thermometers, because they have a shorter time series and there's just a lot more complexities and things that are poorly understood that go into the output of those than there is with just a thermometer-based, ground-based data set. So this graph here shows in the colored lines, it shows different estimates of this atmospheric temperature measurement from satellites. And then the black lines, it shows what we would expect to have seen and see based on models that can model what they would expect the atmosphere to do in terms of temperature over time. And so you do see less warming in the satellite data set, and you see that it's on the low side of what the models would expect. But this certainly does not invalidate the large amount of warming that we've seen down here on the surface. And it also, I would say, does not suggest that the models shouldn't be trusted in terms of their atmospheric changes. Speaking of models, another thing that we get all the time is, oh, climate models are no good. You can't predict weather, or you can't predict climate, 50 years from now or 100 years from now. How could you do that? We can't even predict the weather for next week. You've got to be kidding that we can actually predict the climate that far into the future. Well, I think that comment comes from a basic misunderstanding about what climate models are trying to do, what they're built to do. They're completely different than weather models. It's a totally different process. So climate models are trying to identify what is the likely range of temperatures and sort of the average conditions some given time in the future in a given part of the world. And really, they're trying to do this globally. But they're not trying to come up with, is it going to rain on this day? Is it going to be 80-degree high or a 45-degree high? They're trying to just sort of come up with based on the energy balance of the planet and the variety of processes that happen in the atmosphere, in the oceans, and on land, they're trying to come up with the sort of most common conditions that happen. And you'll run the model out and it will make predictions for exactly what a given day is going to look like. But really what you're looking at is trying to average that over the long term and get an answer. And so, so the models are actually remarkably good at what they do. They're not designed to be like weather models. They're different than that. And there we go. And so if you want to get a comparison of what the models have projected versus what we've actually seen in terms of observations, here you have in the colored lines the observed surface temperatures of the planet over time, and we can compare them to model projections that were done in about 2004 on the left, and model projections that are more recent from about 2011 on the right. And if you go, there's a dotted vertical line on both of these. That shows essentially the time point when the models were the latest data the models had at the time they were run, essentially. And so anything that happened before that date is can be compared to data that was already available at the time the models were run, and anything that happens after that is essentially a prediction of the future, a projection forward into the future. If you look on the left-hand side, really the models since 2000 there have done well, and let me say the black line is the average of a dozen models, or a couple dozen models probably. The gray shaded area shows the 95% range of what those models suggested would happen. So all the most common results are all encompassed by that gray area there. And no one model is going to be right. Nobody thinks any one model is right. They're just trying to get an approximation of what the future would look like. Well, the bottom line is back in 2004, the models made excellent projections relative to what has happened since then. In 2011, the projections were also good. You see a set of dashed lines. In this case, those dashed lines are an attempt to compensate for the fact that when you run these models, you have to guess what future greenhouse gas emissions are going to be, and other what we call forcings that would drive the climate warmer or colder. And so in the dashed lines, they're trying to compensate for what actually happened instead of what was given to the models over that time period. And so you see that in either case, the models are actually doing a great job of capturing approximately what the climate is doing over time. Okay, what about this argument about ice cores? The ice cores show that the warming happens first. I addressed this a little bit in the question period last time. So ice cores show that when you look over the ice ages, over the glacial cycles, way back into the past, you get little bubbles of air out of these ice cores and that show what the atmospheric composition was in some layer of ice that was set down hundreds of thousands of years ago. And you can get some isotopic measurements that suggest what the approximate temperature was in that region. And they suggest that warming happened before the CO2 going up. And so really, that doesn't prove anything about CO2 is what the argument is, that CO2 would cause warming. Well, in reality, it's true that the increases in CO2 usually follow some warming. And you can see that, here's an 800,000 year record from ice cores of CO2 on the top and temperature on the bottom. And you've seen this in previous presentations, that there's real strong parallels here between CO2 and temperature over time. The warming does start first, slightly earlier than the CO2 increase. But what's happening is that the orbital cycles are changing the distribution of energy coming into the planet. And they start warming one portion of the Earth. And what happens is, as the Earth starts to warm, CO2 starts coming out of the oceans. And that CO2 then amplifies that initial warming and essentially accelerates the process of coming out of an ice age. The CO2 is well mixed through the atmosphere, so it's warming the planet uniformly. And so these two things are happening in tandem, and they're sort of feeding back on each other. So CO2 causes warming, and rising temperature causes CO2 rise. They work together. And in these ice age shifts, about 90% of the warming is happening after the CO2 is rising. So it's not that these things are totally independent, but they're not kicked off by CO2. They're kicked off by these changes in the planet's orientation relative to the sun. Okay, myth 9, climate scientists play up climate change for the money. Yeah, just about any climate scientist could have gotten a job out of college that would have paid them more than they would make after 10 or 15 years as a climate scientist. So that's kind of ridiculous on its face, because climate scientists tend to be highly trained and very good in math, analytical skills that would allow them to go into either something like finance or the oil industry and make a ton of money if they chose to. But climate scientists are motivated by other things. They want to find out, they want to make new discoveries. They want to find out what's really driving the world. And also, they're not making a ton of money off government grants. I know that's a thing that's out there too, a myth that's out there, but it's not the case. So if you had like a $500,000 grant, which sounds like a lot of money, that came into a scientist, first of all, the university would take basically a third of that money off the top just for providing an office and internet and power, and the library. Then probably the bulk of it, 250 or 300,000, would go to researchers who are actually doing the main portion of the work on the project, graduate students, postdoctoral researchers. There'd be some money that would go towards supplies and travel, and maybe the scientist would get a day to at most a month of salary per year from that grant. And any of the university climate scientists are unlikely to actually get paid during the summer by the universities. So this would go towards their summer salary potentially, but they're certainly not getting rich off of the grants that they write. Basically, this myth is an attempt to shoot the messenger. But the reality is that the message is strong. The message is built on a whole bunch of research over time. And so, it's kind of an irrelevant point. Myth number 10, climate alarmists always catastrophize. Climate change is actually a good thing, right? So I hear this sometimes. And the thing is that we've built our society, and natural ecosystems are basically evolved to deal with this long, stable period of climate that we've had in the recent millennia. And changes in that climate are going to cause problems because we're not built to deal with that. And they're especially going to cause problems for the poorest people in the world, the people who have the least capacity to adapt to these changes. So yes, some high latitude regions that are cold now are likely to benefit from the changing climate in terms of maybe being able to grow more crops, having a longer growing season. But there have been thousands of studies on this topic, and on balance, the increases in temperature, the changes in precipitation are going to be negatives for global agriculture, for health, particularly in developing countries, for the economy globally and in most countries, and of course for the environment as well. And if we just look here in Indiana, we can see in this graph of number of days per month that are different temperatures. And the most pleasant days are in green. They're the mild days that have high temperatures between 65 and 85 degrees Fahrenheit. The warm days or the hot days are in yellow, and the extremely hot days are in red. We see in the past we've had a lot of mild days sort of throughout the year, with the exception of winter, of course. If you looked forward under a medium emission scenario, sort of the optimistic trajectory that we might be on now, we see that summers become a lot more unpleasant. If we went to a high emission scenario where we just sort of didn't try to regulate or reduce our emissions going forward at all, then this is what the 2080s would look like. Really, really uncomfortable summers here in Indiana. So I would not say that climate change is good for Indiana, and I encourage you to check out the Indiana Climate Change Impacts Assessment for more specific impacts in Indiana if you haven't seen it already, if you didn't see Melissa Whitholm's presentation to kick off this series as well. Okay, and this list goes to 11. This is the last one I'm going to cover, but it is that fixing climate change is too expensive. That's a myth that you hear all the time. And the reality is it's just not true. There are a variety of ways that we can try to fix climate change. Some of the big ones are developing carbon-free energy sources, increasing our use of energy efficiency, helping slow population growth globally, reducing consumption per person. These are all levers that we could potentially use. Some of them would be more challenging than others to actually sort of turn that knob to dial down climate change. But the reality is that some of them are basically painless and even better than painless. So transitioning to carbon-free renewable energy is already happening, and it's happening faster and faster because it's cheaper. Renewable energy is cheaper in many parts of the world, I'd say most parts of the world, than the traditional fossil fuel energy generation. So there have been a bunch of analyses on this, and if this is a surprise to you, you shouldn't be ashamed, because this is a recent change. The prices of solar and wind energy have been dropping like crazy over the last decade or so. Also, energy efficiency, if we go that route, it saves money, and as technologies improve, it doesn't really, you can make your life better. You don't lose quality of life, and you save money by adopting energy efficient practices of a variety of kinds. And then with the population growth issue, the most effective way to do that is to educate girls in countries around the world, the developing countries where populations are growing fastest. If you educate girls and empower them, give them new opportunities, that ends up slowing down population growth in those regions of the world. So there's not a doom and gloom message in here. A little bit of evidence on the renewable energy side. So this is the change in cost of producing energy from, if you look at sort of all the costs of producing energy from a given kind of technology over the life of a plant. This is how the costs have changed over time. And what you see, if you look at the latest numbers on this graph, is that the cheapest technologies for producing energy are wind and solar. And solar continues to drop fast, even faster than wind. And so pretty soon it's going to be really uneconomical to try to do anything else. And you see this right here in Indiana, frankly. In yesterday's news, one of our big energy companies from southern Indiana, mainly, Vectren, put out a plan that said what they want to do in the future is essentially close their coal plants and move very strongly towards renewables as fast as possible, in the next decade or so, or a couple decades. And the reason that they want to do this is not for environmental reasons, it's because of economic reasons. It's because it's going to cost less. It's going to save their consumers money to move rapidly towards renewables. So this is good news. And it's something that is really fast moving and happening now. There's major changes in efficiency coming without sacrifice. You can see that just in vehicles. If you look here at the bold numbers, you can see that the electric vehicles, which are in green, tend to get something like 120 or 100 and up to 136 miles per gallon equivalent. They're just much more energy efficient than regular gas vehicles. And this change is coming fast. We're going to see more and more electric vehicles on the road really quickly. Anyway, that's the miss. I want to try to save a little bit of time for questions, but you can find great information about climate change myths and the real answers to them. If we don't get to yours in the questions, I encourage you to look at this first website, skepticalscience.com. There's a global weirding series of videos done by Catherine Hayhoe that are fantastic. I've got a link here as well. There's a few different government sites here that go into various sort of climate change myths and explain the actual science. So I recommend checking any of these out. And then, of course, here's our digital business card. You're welcome to contact any of us on the screen with more questions. And we'll take some questions now. I'll put this digital card back up in just a second, but next time we hope you can join us for tips for tough conversations about climate change in Indiana. So I'll put the business card back up now, and we have just a few minutes for questions, I think.
Thank you, Jeff. That was very fun. Maybe fun's not the right word. Maybe I've been stuck in my house for too long these last few months, but it was very informative and useful to hear from somebody who is an expert in this area and really understands this area. And I hope everybody on this call really appreciates how lucky we are here in Indiana to have such a great resource in Purdue University and in Jeff being here with us at the university. So thank you, Jeff. I'm going to kick off with my own question just because it's moderator privilege. You alluded a little bit, and I ask this having my own response, knowing an answer, but wanting to get your perspective on this. It's something that I get asked very frequently when I go out to communities and talk about climate change, and it really has to do with population. People say to me all the time, this is just because we have too many people, and maybe not really considering the energy intensity of certain countries over others. So maybe you can bust that myth of this is all just about population for us.
Yeah, thank you for bringing that up. I mean, it depends. So what any one person's impact is on the climate is going to depend on how many resources they use, right? And if I do my best to use as much energy as I possibly can, and living in a relatively rich country, and I do all kinds of things, I will have a huge carbon footprint. Well, people in the most populous countries with the expanding populations, they generally are relatively poor and don't have the opportunity to have a large carbon footprint. They don't have much energy accessible to them, and just can't afford to do much. And so, in reality, the population growth is a relatively small worry in the short term, because it's the places where we're adding population to the planet are places where people use, on average, maybe a tenth of the energy and have a tenth of the footprint on climate change that we have here in this country. Really, I think the important thing is to focus on bringing up the standard of living around the world. That will take care of the population growth issue. And then we have to just figure out a way to make sure that other parts of the world have technologies that allow them to bring up their standards of living without blowing up the climate in terms of, really increasing greenhouse gas emissions overall. And we're figuring that out here, and hopefully we can transfer some of that technology to other parts of the world as well to help them raise their standards of living.
Thank you, Jeff. Now that I've gotten my moderator privileges out of the way, I'll move on to some questions that were in the chat box. One question, and before I ask this question, I will put in a plug for the next session that you'll be hosting with us, which is session 6, next Thursday, same time, same place, which is going to dig into those solutions of climate change. I'm really glad you went into that last Mythbuster on, it's just too expensive, because that's certainly not the case. But Stacy had a question. I wrote down part of it, but I could probably get back to the whole thing. So Stacy's question was, why do energy companies ask me to pay extra for clean energy if it's cheaper? Is it to fund the initial investment that moves us away from fossil fuels, or what's going on there?
Yeah, personally, I think that's a racket. They, I think, have in the past wanted their customers to absorb these theoretical costs of renewable energy being more expensive, but it's just not. I mean, unless they have a bad agreement through which I guess there are a couple things. So the prices have changed so fast that if you bought into that 10 years ago, it may have been more expensive, but now it's not. And often they were going sort of outside of their network to buy this renewable energy from some other source, and it may have cost them a little bit more money to do that. But I think that a real problem with those programs is that it doesn't necessarily guarantee that you are buying additional renewable resources being put on the grid. Unless you confirm with them that, for every dollar you spend, they're putting $1 into construction of new renewable energy plants, essentially, then you're not necessarily adding much benefit. Now, it does, though, signal theoretically to the energy companies that they have a customer base that cares about this. But in the end, I think economics is going to drive this, and really, because renewables are now the best cost option, they should just be going that way rapidly. And we've seen that with NIPSCO in northern Indiana, and now we've seen that as of yesterday or a couple days ago with Vectren in southern Indiana. And now we're just waiting for the other maybe 3 largest utilities in Indiana to go along that path as well.
Great, thank you. I'm going to combine these next 2 questions because they're asking for somewhat similar responses. So Greg and Marilyn had asked earlier that it appears orbital mechanics are actually cooling our atmosphere, reducing the heat. Can you characterize the impact of orbital mechanics, e.g. compare the impact of increased CO2, methane, and other greenhouse gases? Next question, which is sort of along those same lines, the focus was on CO2, but what are the relative impacts of methane and other greenhouse gases? So I think what Greg and Marilyn were trying to ask is that, the scale of impact for the orbital changes compared to greenhouse gases, and digging into that as sort of a subpoint, within greenhouse gases, CO2, methane, what are those contributions? So how do we know, and how do we measure, and what are the different relative contributions of those different forcings on our climate today?
Sure. So the orbital forcings are tiny. That effect is really, really small. And I mean, you have to remember that these are cycles that are ranging from 100,000 years to 23,000 years, going back and forth. And so what happens over the course of a few decades is negligible. And that's the time scale that we're seeing these increases in forcing from greenhouse gases and in the warming that we're seeing. As when it comes to the relative influences of CO2 and nitrous oxide and methane, and some of the other gases and forcing factors that are anthropogenic, like HFCs. I don't have the exact numbers in my head, and I'm sorry that I didn't put the graph in the presentation on this, but I would say that the effect of CO2 is similar to that of all the other gases combined. CO2 is not a stronger greenhouse gas than these other gases, but we're emitting so much more of it than the other gases that it has by far the strongest effect, because CO2 is the primary product when we're burning any of these carbon-containing fossil fuels. So yeah, methane is maybe 20 to 30 times more powerful. But we're contributing to emission of less of it, and methane is also shorter lived in the atmosphere. There are some important things though having to do with like HFCs, with some of these fluorocarbons that are man-made. They have incredibly long residence times in the atmosphere, and they're very powerful. So if you want to look at a good way to reduce greenhouse gas emissions for relatively little money, it can be trying to contain the releases of some of these gases that we use in our air conditioners, refrigerators, that sort of appliances, because their effects are so strong.
Thank you, Jeff. Another question that we have, we try to have optimism when we talk about this, right? This is not a hopeless situation, because there are solutions to this problem. But Leslie asks, what about the feeling on the other end of the spectrum that it's too late? How do you deal with this? By how much do we need to reduce carbon emissions, and how much time do we have to do this? And so that's a question I get a lot as well. Is there really enough time to do anything about this?
Yeah, I think it's never too late, and it's never too early in a way. I mean, everything we do contributes to reducing the amount of climate change that happens down the line. And I sort of feel like every day you need to wake up and deal with this issue one way or the other. It sort of hit reset and start over. I mean, it's a whole. I think I mentioned this recently. There are many tipping points that are out there. There are many sort of levels of CO2 that might trigger this bad outcome or that bad outcome. Realistically, we don't know what any of those thresholds are. We just are trying to avoid them, minimize the impacts on our society going forward. And so the more CO2 we're able to avoid releasing now, and the more greenhouse gases we're able to avoid releasing now, the better off we'll be later. So I'm sorry I can't have an exact answer about a threshold, but it's just sort of always doing more is going to be better.
I agree. We're just past the 4 o'clock hour. We always advertise these as lasting approximately 1 hour, not exactly 1 hour. So we'll go ahead and ask one more question here. Let me do a quick scroll. Okay, so the last question also goes back to solutions, and particularly with electric cars. Mark was asking, are electric power cars an interim solution to reducing pollution until hydrogen-powered cars become marketable? And then somebody else had chimed in, yeah, is this research dead? I remember it was all the rage early on, these hydrogen-powered cars. What do you know about hydrogen-powered cars, Jeff?
Well, let me go back. I saw something in the comments about additional degrees of warming being worse than the last. And yes, I do think that as we as we go forward, the consequences are going to become more dire as the warming continues, relative to what they are now. So another degree of warming on top of 1 degree of warming is going to be worse than just that first degree of warming. So it becomes increasingly urgent to deal with this. As far as hydrogen cars are concerned, the technology is fine, but the infrastructure is basically rapidly getting built out for electric cars, and batteries are getting better and better all the time. So my personal outlook on this is that hydrogen cars are just going to lose the technology race, because electric cars are already fantastic and are just going to be much, much better before and have an infrastructure in place, and before hydrogen cars are really going to get out of the gate successfully. There's a couple tiny markets where you can find some of them, but I just don't see, despite the technology being probably just fine, I just don't see them being relevant if we go forward a couple decades.
I'm just scrolling down and saw the question that you had answered about the increasing impact on each degree of warming. So thank you for addressing that. You are ahead of me on these comments. You are a much better multitasker than me. So thank you very much, everybody, for joining. Thank you, Jeff, for being our speaker today. Thank you, Hans, Austin, and Beth for co-hosting this great series. And we wish everyone a great day.